Hello and welcome back. We are taking a look at exercise number 5 here. We're going to show that n squared minus n is not in the set of little o of n squared. If you don't remember what little o of n squared actually means, we're saying that for all m greater than 0, there exists an n naught greater than 0, that for all n greater than n naught, f of n is going to be less than or equal to m times g of n, but we are trying to find naught in the set of, so we do some flipping here, and we're going to end up with finding an m. So there exists an m greater than 0, that for all n naught greater than 0, there exists an n greater than n naught, where f of n needs to be strictly greater than m times g of n. So what we know is that we're going to try and find, we're going to basically define an m and define an n greater than n naught, where this is going to hold true. Now, in order to define the m, we can pick pretty much any value, right? We don't have access to n or n naught when we pick it, but when we pick n, because n has this added constraint of being strictly greater than n naught, we are going to want to make sure that when we pick our n, we do define it in terms of n naught, one way or another. Okay, so starting with that information, let's go ahead and rewrite the actual inequality with this information here. N squared minus 8n is going to need to be strictly greater than m times n squared. So starting with this information, we realize that we have that difference of sums again. So we're going to use that factoring out trick, and we're going to pull we're gonna pull out that n squared. So n squared gets pulled out, and this becomes 1 minus 8n greater than m times n squared. Now, oh, whoops. You got to pull it out here too. Silly me. And 8 over n. Now, if we want to be able to sort of figure out our n value here, we know that we're going to need to do something with this term, and we have a subtraction here, and we only have a 1 here. So what we're going to want to do is, given the way that this inequality is, we're going to want to be able to say that 8 over n is going to be greater than a half. We want to be able to pick an n where 8 over n is going to be less than a half. And so here we can see that n is like 8 over n. To get equal to a half, we would have to pick an n of 16. So if we pick an n of at least 17, we know that we're going to be less than a half. So let's go with n needs to be greater than 17. Well, I guess n needs to be greater than 16 for this to work. So if n is greater than 16, we're going to be able to say that n squared 1 minus 8 over n is going to be greater than, that's going to be less than a half. So altogether, 1 minus something less than a half is going to be greater than a half. Altogether, this is going to be less than n squared over 2. Okay, so that's great. So now we've got that first term, and we don't want to lose that term. Now we need to figure out our term for m. How are we going to pick our m so that this works? Thankfully, this is actually a really, really easy one. When we look at n squared greater than m times n squared, like this, we can see that the left-hand side is basically just saying 1/2 times n squared needs to be greater than m times n squared. So as soon as we see that, we realize that our m just needs to be less than a half, and we're going to be able to pick something where this is going to work to be true. So thankfully, that side is pretty easy. Now, we did say that we need to make sure that when we pick our n, it is going to be in terms of n naught. We do need to bind it by that lower value. So we either need to be greater than 16, or we need to be greater than n naught plus 1 to ensure that we're pushing ourselves up over that fractional value of n naught. So we can let m equal a half, whoops, and we're just defining these in the same order that they appear. So we let m equal a half. We're going to let n naught greater than 0 be arbitrary. Then we can should have done this on another line. Let n equal the max between our two values that we found, n naught plus 1 and 16. And if we do that, no, that can't be 16. That is going to have to be 17. We're doing that so that we'll be able to then say, observe that n is greater than the max between n naught and 16. Right? N is greater than n naught, and n is greater than 16. So given that, we're able to say that we know that when we go back up to look at this part, 8 over n is going to be less than, or sorry, it's going to be greater than 8 over 16. So we end up being able to see that that factored value is greater than our intermediate value, which is then clearly greater than our 1/2 n squared, giving us our m value as well. So each of these pieces here, I would like to highlight these, I think, is showing that here, when we factor out this side, we were able to determine that an n greater than 16, and not a fraction, right? Obviously not a fraction, so we got to include that value in there, would allow us to prove that this is true. And then we're able to show that if we have an m value that's strictly less than 1/2, this side will definitely be less than this side. Therefore, we can say that our original is definitely going to be greater than the right-hand side of our original. Okay, let's take one more look at another question, just very similar to this in the next video. This one was showing that it's not in the set of little o, and our next one will be in the set of little o. But let's head over to the next video, take a look at it, and see what we can come up with on how we would go about solving another problem like this. Okay, thanks everyone for joining me for this video, and I will see you in the next one.